Welcome to The Explainer. Today, we are diving deep into a technology that could solve one of humanity's absolute biggest challenges, water scarcity. We're talking about desalination, the incredible process of turning our vast, salty oceans into fresh, drinkable water. So, to really get a grip on why this matters, let's start with a story. And this story, well, it felt like the start of an apocalypse for a major city. And it really wasn't that long ago. Back in 2018, the city of Cape Town, South Africa, got dangerously close to something they called Day Zero. And this wasn't just some scary headline. I mean, think about that. It was the terrifyingly real prospect that a modern city of 4 million people would literally run out of water. The taps would just stop. People would have had to queue up just to get a daily ration.
So that just begs the question, right? How is that even possible? I mean, you look at pictures of Earth from space, and what do you see? This beautiful blue marble just covered in water. So how on earth can a major city, or any place really, face a crisis like that?
Well, here's the paradox, and it's a big one. As you can see right here, a whopping 97% of all the water on our planet is saltwater, undrinkable. And most of what's left, it's frozen solid in glaciers and ice caps. That leaves all of us, the entire human race, sharing less than 1%. That's it.
Okay, so when you see a number like that, it makes one idea sound incredibly powerful, almost like a silver bullet. What if we could just tap into that massive 97%? I mean, theoretically, we'd never have to worry about water again, right?
And that's where desalination comes in. Put simply, it's just a fancy word for taking the salt out of salt water. It sounds like magic, but it's really just mimicking what nature already does every day. You know, the sun heats the ocean, pure water evaporates, and it falls back down as fresh rain. We're just trying to do that on demand.
Now, people have known the basic idea for thousands of years, but modern tech really goes down two main paths. The old school way is thermal desalination. You basically just boil salt water and catch the steam, which is pure H2O. But the modern standard, the one you see almost everywhere now, is membrane desalination. Instead of heat, it uses insane amounts of pressure to literally squeeze fresh water through a superfine filter, leaving the salt behind.
And you can see just how old this idea is. Aristotle was thinking about it in ancient Greece. But look at that timeline. For centuries, it was just an idea, a small-scale trick. It's only in the last 20, maybe 30 years that this technology has absolutely exploded onto the global scene.
And that's the key takeaway here. This is not some futuristic fantasy anymore. It's a massive global industry. Today, there are around 16,000 desalination plants chugging away right now, all over the world.
Okay, so let's get into the nitty-gritty. Let's peek inside one of these water factories. How does it actually work? We're going to focus on that most common method, that membrane technology I mentioned, which is called reverse osmosis.
You can really break the whole thing down into 4 main steps. First, you've got intake. Seawater gets sucked in and filtered to get rid of all the big stuff. You know, sand, shells, seaweed, that kind of gunk. Then, step 2, powerful pumps kick in to create some serious pressure. Step 3 is the magic moment, reverse osmosis. That pressurized water is forced through special membranes, and only the tiny water molecules can get through. The salt gets left behind. And finally, post-treatment. The pure water gets a few minerals added back in before it's sent off to the city.
And I really want to stress how important that pressure is. We are talking about 60 bar. To put that in perspective, that's roughly 60 times the normal atmospheric pressure you're feeling right now. It's an immense amount of force, enough to literally rip water molecules away from salt molecules.
You know, here's a fascinating little detail that shows you just how precise this whole process is. The water that comes out of reverse osmosis is so pure, it's actually not good for us to drink. It's kind of flat tasting, and it can even corrode pipes over time. So they actually have to add minerals like calcium and magnesium back into it to make it healthy and taste good.
So this all sounds pretty amazing, right? A perfect solution to our water woes. But there's always a but. In this case, there are actually 3 really big catches: cost, energy, and, well, waste.
First up, the price tag. Building and running these plants is incredibly expensive, and this chart really tells the story. Something like 71% of all desalinated water is produced in high-income countries. It's a solution, yes, but for now it's mostly a solution for the wealthy.
Second, you've got the energy problem. Creating all that pressure takes a mind-boggling amount of electricity. And where does that electricity usually come from? Fossil fuels. This quote here just stops you in your tracks. As of 2010, Saudi Arabia's desalination plants were burning through 1.5 million barrels of oil every single day. We're solving a water problem by making our climate problem worse. It's a tough trade-off.
And that brings us to the third big issue, the waste. You see, for every liter of fresh water you make, you get left with about 1.5 liters of this super concentrated, salty gunk called brine. Think about that. Globally, we are actually producing more of this waste product than we are clean drinking water.
And we're not just talking about slightly saltier water. This stuff is a toxic concentrate. It's often pumped right back into the ocean, but because it's way denser than regular seawater, it sinks to the bottom, and when it settles, it can create these underwater dead zones, suffocating marine life by sucking up all the oxygen. Not good.
Okay, so with all those downsides, it raises a huge question. If this technology is going to be a key part of our future, how on earth do we make it better? How do we fix these problems?
Well, the good news is there are some really smart people working on this. Innovators are tackling each of these problems head-on. To fight the fossil fuel dependency, they're building plants powered by solar and wind. To tackle the cost, they're designing smaller, portable units. And, maybe the coolest part, they're completely rethinking the brine problem.
Yeah, there's this really fascinating shift happening, a push to see brine not as toxic waste, but as a new resource. I mean, how cool is this? Some projects are using it for aquaculture, farming salt-loving fish and seaweed. Others are figuring out how to extract valuable metals and minerals from it. The big idea is to create a circular system where literally nothing goes to waste.
But you know, the biggest game changer might not be a new machine at all. Let's go back to Cape Town for a second. Remember day zero? The city managed to avoid that catastrophe, but it wasn't because they built a bunch of new plants overnight. It was because the people, the citizens themselves, radically changed their behavior. They started conserving water like their lives depended on it, because they did.
And that really leaves us with something to think about, doesn't it? Desalination is, without a doubt, a powerful, almost miraculous technology. It's going to be a huge part of our future. But as we look for answers to our growing water crisis, perhaps the most critical question isn't just about how we produce more water, but about how we learn to value the water we already have.